We are in our office today with Dr. Chia-Hua Kuo, distinguished professor and dean of sports nutrition at University of Taipei. I received his doctorate at University of Texas Austin under Dr. John Ivey, who has contributed greatly to our understanding of sports nutrition. He is now retired. Dr. Kuo is a fellow of the American College of Sports Medicine. He is the editor-in-chief of a very well-regarded journal and also editor for two other sports journals. He's done everything you could think of in his career. He has published over 230 papers. He has a team below him now. Dr. Kuo himself has contributed greatly to what we understand of sports nutrition, and we're very honored and thank you for coming in today, Dr. Kuo.
It's my pleasure.
So can you share with us how's your experience in Virginia?
It's very nice. I think Virginia is very good life experience.
Is it everything that you expected?
Yes,
Okay.
especially I met my old friend, Brennan Harris.
Right.
He's a very nice person.
Speaking of Brennan, what is your connection to William and Mary and Brennan?
Okay, we went to graduate school together at the University of Texas at Austin.
Okay.
For PhD. So we both got PhD. I graduated 1 or 2 years earlier than Brennan. Yeah.
So you guys were not the same cohort, but same. You guys were there at the same time.
Right. But
Okay.
sometimes we are in the same class. Yeah.
Okay. Did Brennan study under Dr. John Ivey as well?
No, it's Dr. Stone,
Stone?
Joe
Okay.
Stone, yes,
Okay.
which is very famous professor in vascular physiology.
Right. There we go. What? So I'm gonna get right into this. What is it that Dr. Brennan? Earlier we were talking about the shelf life, so to speak, of an endothelial cell, right? 2 weeks. And that is the area that Dr. Brendan Harris is working on, right? Like vascular health or endothelial health.
Yes.
Is there anything that he's been working on the last 10, 15 years that really excite you personally?
Yeah, he has published a lot of paper on vascular physiology. So I also learned a lot from Brennan.
Okay. Interesting. And then also earlier I asked you a question about muscle fatigue. I'm like, oh, that's just because you have lactic acid buildup. But you corrected our prior train of thought. You said that's not necessarily the case. Can you share more?
Yeah, if you look at the muscle soreness, that happens normally later after exercise, right? So if you do weight training, right, during the weight training you build up the lactate concentration is going very high, but it will disappear in 1 hour when the oxygen is replenished.
It? 1 hour?
Yeah. 1 hour later you do not see lactate much, but you start to feel sore.
Yes.
Like 1 day or 2 days
Yes.
later, right? So obviously that is not lactate.
Okay.
Lactate has been metabolized quickly in human body. And also if you give, let's say if you give the carbohydrate and fat, right? If you give the same calorie 3 hours before exercise, you found that the end of the exercise, the carbohydrate has higher lactate. And if you consume fat, the lactate is lower. But if you ask the question, which one are fatigue earlier, is the fat, right? So you see low lactate supplement, the supplement give you low lactate,
Right.
have shorter endurance. And the supplement give you high lactate, has longer endurance, right? So that is also give you the idea that the lactate is not the cause of fatigue.
Right.
Interesting. Wow. Yeah, that's completely blown my mind. I've never. Okay, so is this a theory or is this proven that muscle fatigue is associated with senescent cells.
Yeah,
Is there a working theory, or does this have been reproduced so many times?
right. If you look at the time course of the pain, okay, so you challenge your muscle, then you start to feel the pain. It's occur later, right? This is
Right.
what we call delayed onset muscle soreness.
Yes. Okay.
Right, and that is the time of when muscle is already entering the regenerative phase. Right, when you challenge the muscle, you need to recovery. Right, you have the recovery period. You have the very short period that is called phagocytic phase. Okay, and that is the time when immune cell and the bone marrow stem cell get into the muscle and start to have a clear senescent cell, and then repopulating the cell with the new stem cell, right? So the first period is very short, phagocytic. It's what happens when you are doing exercise.
It's happening in real time as you're exercising.
Right, right.
Okay.
And then 3 hours later, depending on what kind of exercise, three hours later, you are already entering the regenerative phase. Okay, so when you have the regeneration, when the cell repopulating, when they reconnect it to the nerve, and that is the time you start to feel the pain.
Wow.
So that means the pain is actually occurred during the late phase of the inflammation, which is what we call regenerative phase.
And it's something like taking something like Tylenol. You're numbing those receptors.
That's very good. Yeah, it's suppressing the
Yeah,
inflammatory.
but they're there. Yeah. Wow.
Okay. So you have, so the, if I'm understanding this correctly, the muscle goes through repair really quickly. Or not phagocytosis happens during real time. The lactic acid clears out really quickly, right, within an hour ish. And then the soreness and, as you said earlier, delayed onset muscle soreness that happens 1 to 2 days post. What is happening during this time to the muscle tissue? Is it literally being rebuilt, or like what's going on in that muscle tissue as you feel sore? You know.
Okay, actually, you have to first know that the muscle is a mixture of many type of cell.
Okay.
You have a myofiber that occupy probably more than 90% of the tissues, this contracted component. Okay, and you also have the stem cell. You have endothelial progenitor cell. You have endothelial cell. You have nerve. You have all sort of different kind of the cell. You have an immune cell there as well. Okay.
Okay.
And for most of the cell, that their lifespan is very short. Okay. So when you have build up of the senescent cell, that would release the signal to trigger regeneration. Right. So periodically you have high senescent cell, low senescent cell, high. You have the cycle like this.
Yes.
Okay. But if you exercise, then you sort of control yourself.
Yes.
You control when I can reset my muscle.
Interesting.
You control the call signal to the bone marrow and to the immune system.
Right. It's actually if you consider muscle as a society of a diverse group of the cell.
Like a country.
Yeah, like a country,
Your
right?
old example.
I love that analogy earlier. How the body is like a country.
Right. And then if you have the challenge, like earthquake or whatever, right? And the people who are fit, the fit cell can survive, and unfit cell are dying, right? And when unfit cell are dying, and when you are regenerating, that system start to feel the pain.
Yeah. In the example, societal pain of losing mass numbers to an earthquake or something.
Right.
Wow.
So all sorts of the challenge and transition is going to bring
Yeah.
pain.
Right.
But that is very short period. But you you bring long period of stability against the challenge.
Yes.
I really love in the prior lecture how you compared the body to a well-functioning country, right? You have a young population, old population. You have all these different specialists, right? But you want to maintain balance and homeostasis. And you guys can get access to that lecture later. Look at our description. The link will be in our bio. So we understand that fatigue now is at least partially attributed to senescent cells. Is that correct?
Yes, that's one factor.
One factor. And what we've learned is, at least the current working theory is Senactiv can activate the bone marrow that goes to your muscle tissue to remove some of that senescent cell clearance. Is that correct?
It's actually exercise can bring blood into the muscle.
Okay.
And the Senactiv can activate the immune cell locally to do their function, which is clearance of the senescent cell.
The bone marrow then replaces the ones that clear.
Okay.
Yes, yes.
That's fascinating. Okay, are there any other plants out there, whether it's traditional Chinese medicine or Ayurvedic or something someone's using in South America that really excites you from a sports nutrition, sports performance perspective?
Okay. I don't really know much about the product in South America,
Okay.
but that is promising area to explore.
Okay.
I'm sure about that. And for the Oriental things that has been used widely, cordyceps. You know cordyceps is?
Yeah.
It's a fungus. It's
parasitic, right? Yeah.
Parasitic fungus. And if you have a small animal, it got infected by the parasitic fungus, it would take out the entire body.
Mm-hmm.
Right? So it's very toxic for small animal, like
Yes.
an ant
Yeah.
or like small-
Caterpillar.
Right.
Yeah.
And yeah, so but you know, that small things to human body is very big. We can handle that stress
Right.
by mobilizing our immune system and the bone marrow stem cell. So we have tried that in human body before. 1 hour before exercise, you take cordyceps.
Okay.
You see the normal exercise response gets shortened. For example, exercise will bring bone marrow stem cell into the muscle. And then those stem cells will mature into the muscle. Okay. And
So
if
you're
you
saying
have
that cordyceps optimizes exercise, so you don't need to exercise as much?
it's actually prime your
the muscle.
exercise response.
Wow.
So that
This is
Accelerate.
completely not planned.
accelerate the bone marrow stem cell into the muscle.
Wow.
So that
We've always
result-
thought cordyceps just had like lung support.
Or just general adaptogen helps you fight off fatigue or stress, but it actually primes the muscle to essentially perform better. Is that
right. Actually, we have the same thought that traditionally in Oriental medicine, that the cordyceps is used for pulmonary disease.
Yeah, like carrying
right?
more oxygen in every cell.
Right. But when we measure the VO2 max, cardiopulmonary function, we do not see any difference.
Really?
Yeah, but we see the difference in the muscle.
wow? Well, can you share what the dosage was?
I think it's 2 grams.
2 grams. Okay.
That's not bad. Wow.
2 grams, 1 hour before exercise.
Okay.
Wow.
Um,
2 grams.
Now I'm gonna keep this short. Do you have any academic advice or any advice at all for someone that wants to follow your footsteps, study sports nutrition? Is there any advice for them if as they prepare for that journey into that so-called? Do you have any advice for them as they prepare for that journey into potentially teaching or lecturing or just doing research in sports nutrition?
Yes, for professionals, you always want to focus on the most important marker that people care. Okay, the first one is performance, right? Especially for older people, right? Older people performance is dropping, and that is correlate with how long they can survive.
Yes.
Performance is number one, and the body composition, how they look, yeah, they can also scientifically measure. And the third one is longevity. So you always want to focus on these three scientific measures. You don't want to pay your attention on molecular marker,
Okay.
because sometimes you see the molecular marker is going worse and then later going better in opposite direction.
Right. This goes back to your earlier conversation. Trying to judge like just relative health just through molecular markers alone at the bare minimum cause some confusion, because they could go up, they could go down. Whereas you look at when you take a step back and you're looking at, let's say, what you said earlier, maybe weight gain over time or weight loss over time. What did you say, like longevity, right? Like looking at more, I guess, more macro or more multicellular functions.
It's
related
more
functions?
system.
More system-based functions. Okay. So to someone starting out, don't get caught up too much into the details of molecular compounds per se, but look at more system-based.
Right. The molecular mechanism, unfortunately, in human body is not, obviously, it's not fully characterized.
Right.
For a simple reason, if we know the human body well, we should be able to solve a lot of important questions like a cancer, cardiovascular disease. And now there's no solve, right? We cannot solve the problem at this moment. So that is demonstration that we know very little about the human body.
True.
Right? Sure. So you want to always focus on the most important marker: performance, body composition, and longevity.
Right.
And then you look at the molecular marker. Okay? If you never want to use the molecular mechanism to give a recommendation.
Interesting.
You want to look at the primary scientific outcome and make the recommendation. So that is my recommendation for the scientists and also professionals.
Okay.
The second thing is you want to focus on balance. Balance means cell death and cell regeneration, right? And keeping the body weight static. That is what we call the balance. Because life is full of unexpected challenge.
Mm-hmm.
Right.
When you have the challenge, the cell dying, right? And then what it brings is the benefit that you can sustain the same challenge better. You solve the problem faster, right? Because of the adaptation, right? So you have the downside, you have upside. So the life is depletion, kill your cell, and then regenerating your cell, prosperity, right? So you want to have the balance, but you need to have the ultimate measure. What is the best? That is body weight, the total cell number of your body.
And I remember earlier that was pretty much that was a good part of your seminar was by maintaining whatever is the optimal body weight to you over time. For a good example for especially us, right? We want to put on a lot of muscle mass, but now you're talking like what you said earlier. Now you're talking about billions, if not trillions, of additional cells that are now recruiting from your bone marrow that depletes you over time. Because as you said earlier, bone mass as a percentage of your weight is also a very strong predictor of mortality, right? Or
Yes.
at least bare minimum health span. So this is all fascinating stuff to us. When we were in, I forgot the city name. Was it where's William Mary based out of?
Williamsburg.
So when we were eating in Williamsburg, you shared a very interesting personal story. Because we were eating proteins, we were eating pizzas. And I remember you said you were actually limiting how much protein you take because protein breaks down the nitrogen, which then causes growth in your body, right? And you don't, but like all things grow in your body, other things, including bad things, can also grow in your body, right? And since you're at a different stage in your life now, So you're trying to maintain a limit on your growth. Is that correct?
Yes.
Can you share more with us that
Yeah, sure.
process?
You know, the human society tend to standardize what is the correct, what is the recommended protein intake for everybody, right?
Yeah.
And you know what kind of the marker they use? You need to have a scientific marker to make the decision. What kind of diet is the best, right? And the marker in WHO and also in America is using two keywords. One is growth and one is lactation.
Do you say lactation?
Lactation, growth and lactation. Because after World War
For
II,
population.
yeah, you know what happened after World War II? Everybody poor, right?
Yes.
And the slow growth rate is the concern. And therefore, at that period, we have that experience. So we think growth and lactation, to having baby is
Yes.
most important things, right? And you know, United States is very good in mass production.
Right.
So if you ask the question, what kind of the product is promoting growth the most? Protein, right? And who make the best protein? This country, right?
That's true.
Yeah, and
And then
if everybody,
in the mind, everyone thinks you need to have a certain amount of grams per body weight.
right?
Protein, yeah.
So in the society, the government make the decision what is the recommended protein
Intake,
level,
yeah.
and if you take that as a becoming your behavior, then you are going to grow and grow and grow, right? And your body weight is going to be
Wow.
not very easy to control.
Wow. Okay.
So that's why I take very low protein, because
you
I look
share-
at the most important data I look at is we call geometric framework study, and that is using different marker to measure to give the recommendation. The geometric framework is a study that gives 30 different diet and asks the question how long they can survive.
Oh, that was a study like examining like Mediterranean diet, right? Plant-based diet. Oh, I guess can you
30
sh-
different.
30 different
Yeah,
diets.
you have the high protein, high carbohydrate, and high fat.
Okay.
And then you have you have 10 different
Variations
dietary
of that.
option, vary by caloric intake,
Oh wow.
right? And that is completely different result than the dietary guideline made in this country.
What were the findings of that geometric frame study? Like, do you want, I guess, more carbohydrates or more fats?
In that study, the most important finding is that if you have the protein composition lower than 5%, then your body weight would not grow,
5%.
right? If you lower than 4%, the body weight start to decline, especially for a low calorie intake group,
Okay.
right? So that also demonstrates that protein are important for growth, right? But if you have the high protein, then the animal will grow very fast and die early.
What was the high protein cutoff? Like 20%?
It's linear. It's
It's
sort of linear. In human, there's a correlational study, the cohort study. So they asked the question, also in this country, if you have the protein lower than 10% compared to recommended value that is 10 to 20%, and there's another level is above 20%. And then you ask the correlation. What is the people, they have 18 years survival rate. 18 years. The highest survival rate is the high carbohydrate, low
Really?
protein. It's actually low protein. Low protein, it has the highest longevity.
Well, can you? You don't have to answer this. What is your daily target for protein? Is it half a gram per kilogram, 1 gram per kilogram?
Well, I try to avoid everything that has,
a lot of
you
protein.
know, if you just in Taiwan, we have very good agriculture. So
Yeah.
if you look at the rice, what is the protein composition in rice? It's 6%.
Really? Rice has
So
6% protein?
6%. Yeah, so that means if I just have a rice, then the protein standard is already reached. So that means if you have like a piece of egg or
Yeah.
vegetable, you are already satisfied yourself.
But this would this be the recommendation for younger male and females as well, or just maintain around 5% protein intake?
Well, this is also applied to different species.
Yeah, okay. Understood.
But protein is promoting growth. So
Yeah.
if you have a high protein, your body weight is not controllable.
Control. Okay. Very interesting.
And also in that experiment, it also shows that comparing 5% and 18% of the protein. So if you have the animal that injected with, transplant with the tumor, okay, and then you give 2 different diet, and you watch the tumor growth, right? You know what happened? 18%, the tumor is grow very fast. 5% grow slowly.
So tumors feed not off just sugar, but they also need protein to grow.
Yes.
Okay.
Yeah. So anything promote growth, they cannot distinguish that you are tumor or normal cell
Right.
in the entire body. But
Wow.
the tumor grow faster, right? So you need more.
Going back to the rice example, does the quality of the protein matter? Because some proteins are more digestible, right? Was the PDCA matrix like? So for example, milk protein is easily digestible, whereas pea protein or hemp protein is harder to digest. Does the quality of the protein matter?
Yes, yeah, that is. You talk about the plant protein,
Right,
not
yeah.
that easy to be digested. And but if you talk about soy,
So right.
okay, I talk about soy is a high protein product, right?
Yeah.
So you talk about the whole soy compared to whey protein, pure whey
Yeah.
protein. If you talk about, I don't know about the longevity, but if you look at performance recovery, they are almost the same.
Wow. Okay.
So if you take the soy and the whey protein, you eat 2 to 3 hours before exercise. On day 2, they recover at the same rate.
Wow.
I remember this conversation now in Taiwan because there was a concern back in the 90s and 2000s that soy protein might cause elevated estrogen levels in men. That theory's been debunked now, right? It's no longer valid. Consumption of soy protein will raise your estrogen level.
Well, I'm not very certain about that.
Okay. Well, exactly what the video did. Let me see. So I remember from our earlier from the seminar, in a perfect world, you maintain your weight and muscle mass up until about 70, correct? Basically
Me?
the first 3/4 of your life you want to be growing slowly, and then minimize the decline, right? Because that's what you saw in the people who lived the longest. They had a very they had a slow growth, but also a slow decline, right?
That's right. Yeah.
So in actuality, if we were trying to expand just our entire expand our lifespan, maybe not necessarily health span, but lifespan, you don't want to grow too fast. Essentially, is that what you're saying?
Actually, it's a very simple concept. If you can control your cell death and cell regeneration and make the entire cell population in the middle age and younger, and that is the most functional body, right?
Yeah.
But one of the reasons we cannot do it is because we are promoting growth. Because when you are promoting growth, you will eventually face the thermodynamic problem.
Right, it's about how much you can grow, right? Before
Right.
you decline.
Right.
So
So most of the people, they know the first 2 principles. They control cell death. You exercise kills
yeah.
unhealthy cell. nutrition,
Right.
recover, right? And you have a new cell population in the muscle. But if you do not control the whole body weight, for long term, it's not going to be good.
Very interesting. I think that's it.
For optimal performance, sports performance, could you give us one quick recap of why Senactiv is so important for optimal sports performance?
Right. I have to be honest that the things we know is the Senactiv can improve your performance, and that result is very reproducible. Okay, that is one thing. And the reason behind, we are still exploring. Okay, and I think that the things we are confident is that the Senactiv are able to activate your immune system. And the evidence is we look at the post-exercise senescent cell reduction is higher when you have the Senactiv in skeletal muscle, human skeletal muscle.
Perfect.